Okay, so this is question number 18. It asks us to draw a free body diagram for objects 1 and 2 and determine the value of the tension in the cable and the mass of object 1. So free body diagrams, let's first look at number 1. It says it's at equilibrium, so it's not accelerating. So all the forces are equal. So if I look at number 1, I have the force of gravity down, and that would be equal to the tension up. Number 2, I have the force of gravity on 2, which is just 9.81 times the mass. So maybe I'll just write this in there, 1.96 newtons. And then I have this tension, and I have that tension. Now, one thing to note, because we have a pulley there, this tension and this tension are going to be the same. So that would be helpful in kind of answering it, and I think that would be important for number B, number 2. So those are free body diagrams for all of them. If we want to find this tension and this force of gravity or that tension, we do need to draw a vector addition for number 2. So we have the force of gravity on 2. So this is my force of gravity, that's down, is equal to this tension. So that tension right here, that's going up at an angle, is just equal to the other tension, which is the one we're trying to find. That's this T, is that tension. So again, I add all those vectors together and I get back to 0. So force of gravity plus the tension to the right, this one, plus the tension up to the left, that one, and I get my triangle. Now I can look at some of these angles just to make sure that it's a right triangle. I guess like this angle here is 60, which means this is 30. And then when I have this one going up here, this angle's 60. So I have my right angle there. So I have that. If I split that into kind of a right triangle, that's 60, so that means this angle has to be 30. And if that's 30, then this angle has to be 60. Now I kind of have some angles there to figure it out. So to find that tension that I've circled, probably want to use sine. So if we are getting a different answer, maybe we're not using the right trig ratio. So the sine of 60 degrees is equal to my opposite side, which is the tension, divided by my hypotenuse, which is the force of gravity. So my force of gravity, which is 1.962 newtons, times the sine of 60 degrees, gives me 1.7 newtons. So that's B, the first part of it. To answer the mass of object 1, I probably want to move over here. The big idea there is that the tension is equal to the force of gravity. So tension is equal to mg for that thing, because those are the only two forces acting on it, and it's not accelerating. So tension divided by g is my mass. So I have my tension of 1.7 newtons divided by 9.81, and I get 0.17 kilograms. So the important part to nail, I think, is this vector addition. So we have the force of gravity down plus that tension and that tension. So these are all the forces acting on object number 2, and it's at equilibrium. The next part is actually determining these angles. So like if I look at tension 1, so I look at this tension here, and I look on the diagram, there's a 60-degree angle with that vertical wall that it meets. So that means that inside that triangle, the other side of it needs to be 30 degrees. If I divide this into a right triangle now with that 30 degrees, that means this one down here is 60. So I kind of have those angles. Then when I look at this other tension, so the one I tried to find, I know that there's a 60-degree angle here with that horizontal line. So that's just straight from the diagram. And if I divide that into another smaller triangle, so I keep that 60, that means that this angle needs to be 30 because all the angles in a triangle add up to 180. So then there's my right angle. Then I have my 30 and my 60-degree angle. I can use sine, opposite side over my hypotenuse, and then that gives me my the right vector addition.